Seconds. Check. In today's activity, we are going to take a look at some of the terminology that we've been able to define in a particular experiment. So in this experiment, I want you to think of two options that you're going to be really interested in. So option A. So would you rather roll two dice 10 times and receive $5 every time you get a double? Or would you rather, for option B, roll two dice 10 times and receive $5 every time you get two even numbers? So before we go through the mechanics of figuring out which option really is the more likely, or that will get you the more money on average, I want you to make a guess. Which option do you think is better? Hopefully, you made a guess. It doesn't matter if you chose the correct option, which was option B, that every time you get any two even numbers, you receive $5. This one will pay out more money on average, but we'll be able to determine that after we go through the breakdown of options. First, what is the experiment that we're running? So recall, the experiment isn't the specific outcomes, but it's the actions that we're performing and the data that we're recording. So what data do we record and what actions are we taking? So take some time to write down what you think the experiment is. Then compare your answer with my possible answer. Hopefully, you're able to make a guess. Mine was that we're rolling two dice and we're going to record the numbers that are face up on the dice. So if we think of the action being performed, that's going to be the rolling of the two dice. The data that we collect is going to be the numbers that are face up. This leads us to the events that we're looking for. So it's not going to be any particular outcome, but what kind of events? So I'm going to say that let event E be that the two dice come up for both two even numbers, and let event F be that you get a double or you receive the same number on both. So we can use classical or the theoretical approach to determine the probability of event E occurring. That is that we get two even numbers. So I want you to take a minute to think, what's the probability of that occurring? If you can work it out, please explain. If you can just give a guess, just write down your guess. What's the probability that we'll get two even numbers when we roll a dice? Hopefully, you were able to write down your guess for that. So the probability is going to be 1 out of 4. So how can we check this? Well, we can break this down into a two-step process. So we roll the first dice, and the chance that it is even is going to be 1/2 because of the 6 options given, 1, 2, 3, 4, 5, 6, 3 of those 6 options will be even. Now, the probability that we roll the second dice is also going to be 1/2. Since these events are independent, we can say that the probability of getting both of them would be 1/2 times 1/2, which would be 1/4. Why do we multiply these two numbers together? That has to deal with the product rule for probabilities. That if two events are independent of one another, the probability of receiving both events is the product of their probabilities. What is the probability of F? So for any roll, the chance that the second roll will match it is going to be 1/6. So for instance, you roll the first dice, it comes up a 2, fine. The probability that you roll the second dice is going to be a 2 is going to be the 1/6. We can check this empirically. So below, I want you to roll a dice. So you can see that you can simulate using the pseudo-random number generator and click the roll button. Your dice roll will show up as D1 and D2. And it could be the numbers, for instance, 5 and 6 or 1 and 3. For 5 and 6, that would fall into the category of neither, being a double or an evens. If you rolled a 1 and 2, that's neither a double or an even. If you rolled a 2 and a 4, that would be an even. So I want you to continue to click the roll button and see what the probability is of getting a double or an even. Which one seems more likely? So you may need to click that roll button, about 30, 40, 50 times. At some point, you'll see that the number of evens becomes more likely than the number of doubles. This is the empirical or experimental approach to determine whether something is going to be more likely. Now, my final question to you is dealing with a bit of statistics. So the above, graph showing all the little dots above doubles, evens, or neither is not going to be a good dot plot, or is it? So you're asked, okay, why could this be a good dot plot? Maybe it is fine. That would be option D. Or this is not a good dot plot because, or should dot plots have a vertical axis? Should dot plots have some outcomes are counted in both categories? Is the data categorical and not quantitative, so should not be used for dot plots? Or again, none of the above, that this is just a fine dot plot. So give your guess and check your answer. Hopefully, you're able to determine that this is not quite a good dot plot, because dot plots are supposed to be categorized in exclusive categories. So the chance that you can get a double and an even can be counted twice. So if you rolled a 2 and a 2, that's both a double and an even, but is counted in both of those categories, which technically it shouldn't be if it's going to be a well-defined dot plot. And that's the end of this fun activity. I hope you enjoyed it.